that, again, I've been saying it, and I'll say it again, if anyone has any sort of speakers, any kind of subject matter that they think would be beneficial to cover, that they're interested in, absolutely let us know, whether it's through the Discord or over email. And if anyone's been having any trouble with any of that, signing in or signing up through the Hornet Hub to be an official member, feel free to stay after we're kind of wrapped up, and we can sort that all out. Or reach out on Discord, by whatever means. Yeah, so the theme of this meeting is going to be kind of a framework by which you can kind of, I suppose, think of how you might be able to kind of leverage data in the way that would suit the subject matter that you're addressing. I know we have a lot of, last meeting we had a lot of CS folks, but we have a number of engineers as well, but we have a whole spread of majors, so I think it's good to kind of just make sure everyone's kind of on the same page in that way to some capacity. We're all speaking the same language on some level. And so, especially for the CS folks, they really hammer down techniques for engineering, which is a very useful tool, but I've found that there are, the scientific method, as simple as it is, it's a very useful tool, and the way it's often taught is kind of linear, and I think it shouldn't be etched in stone. And so we'll kind of go over that sort of preliminarily, like initially, I suppose. And then furthermore, we'll kind of then get into what I would consider maybe a fundamental aspect, a key component to, I think, data science that I find very interesting and I think is very helpful sort of method of thinking with data. And so I will say also, if you like this at all, feel free to check out linear models with Dr. Fitz. This is kind of inspired in some capacity by a lecture that was given by Dr. Fitz. It's an awesome class if you want to sharpen your stat skills, and it's definitely, I feel like, helped give me some tools that are like critical for performing analysis. Yeah. Okay. So kind of just right out the gate, and it's no judgment. Who here likes math? Okay, that's awesome. That's awesome, yeah. I will say I kind of started out not being into math, but I've come to realize that it's awesome, and I hope to kind of articulate some of that today, and maybe get some people a little more comfortable speaking in those terms, Though we're not going to, don't be afraid, we're not going to get into too much of the technical, but just as a means by which you can sort of express ideas through math. But before all that,
before we do begin, though, so I can add myself a little bit of buffer time, everyone mind looking to their left, looking to their right, and introducing yourself really quickly. Again, we have sandwiches at the back and cookies. There's vegetarian, ham, and turkey, so feel free to grab one. Again, please make sure to sign in.
How about Really? So you just moved from?
So what's up?
Of this year,
As all ever be.
2024.
As
So
I'll
next
ever be.
year. I mean, that was makes sense. So are you getting your degree from here?
Doing great. I didn't know
No worries, no worries. It's all good. So long as it shows up, we're
What do you
good.
think of
No, I
that?
won't get hung up.
Kind of like it, but I like really
Yeah. What's your
Are we going to discuss language models today?
Trying to do what now?
Are we going to discuss language models? NLP?
Okay.
Maybe at the end. There's a generative, like Dolly Mini, which is now Crayon AI, that I used in the presentation. So we'll pick that apart a little bit.
Okay.
But I'm just trying to. Well, yeah. Maybe at the end.
Will you talk about coding, codings, embeddings,
So
and all that?
cool.
Probably not too much of like the
I'm
technical
from a
stuff.
very like
because,
rural
this
town.
is
You're from like a big city.
Yes, sir.
That's a lot.
I
That's
saw
like
something
so long. My entire
presenting actual detail on how to do that. Data representation, language models, tokens, but so you're not going to discuss it. You are.
I commute like I live in
So should I send you the topic?
like it's like literally
No, we're good. We did
it's like
the
a
For one presentation, for one presentation.
yes.
Let's get on.
Because if not, it's going to do language models, then it can change the topic in some way.
No, we're not really gonna get too in
Ready?
All right, let's now begin properly because I have everything set up. All right.
All right. So yeah, let's get into it. So let's start with the scientific method. Do I just space? So I go. Let's go to yeah. So I mean, I'm sure all of you have heard about it. It's pretty elementary. It's just the process by which you are kind of conducting a scientific study, and typically it goes through the process of problem, question, and then hypothesizing, and I suppose this is a little bit in a different order, but that's kind of the point I'm going to get to, is that I won't go through every step. I'm sure you're all able to look up in detail all the elements and how they are discretely divided independently per major, because everyone has their own sort of method of going about things. Sure.
What's the difference between a data scientist and a statistician?
That's a great question. So I would say it really depends. It's like rectangles and squares. You can think of it. So a statistician might perform, actually, and it's too bad that Dr. Fitz just left, but that a statistician can perform all sorts of different kinds of functions. Though in a modern sense, oftentimes because the demand is so high, they are going to be working with data. In some capacity, somewhere, you'll see a statistician working with data. And the data scientist, it would be very hard to get away from stats. So it's kind of like, again, that's part of the reason why we're looking to get like industry speakers, because title isn't always super indicative of the work that's being done. If the organization is small enough, regardless kind of your background, you will be tasked with sorting out the data, so to speak. And that I would imagine the titles get a little more rigid as you get into academia, where it's maybe a little more formalized, or maybe it's larger institutions. But was that able to kind of answer? Okay. Great question, though. So yeah. In any case, that the whole point is that the process of the scientific method should be organic. It should be a natural thing. You don't have to stick to this sort of, as you see, this linear sort of process, because sometimes, in fact, most oftentimes, you're making an observation. You see something, such as two trees have different colors of green. And that's something you take note of. And then you go, well, why? That's your question. That's your problem. And now you've started the scientific process. Not always will it just be an apparated question that comes to you in the night. That's kind of, there's a rigidity to that I don't think is super reflective of the true exploratory process of what scientific study is. But very much so useful nonetheless, that these should be thought of as blocks you can kind of rearrange. And that you may even get stuck in the experimentation process. And you'll experiment over and over and over and over before you're able to draw any meaningful analysis and especially under scientific rigor, make any sort of conclusion. So that's kind of just, in review, the scientific process. And that in each field, it will probably shake out a little differently, as y'all will have different methods of approach. Any questions, comments, concerns so far? No? Pretty straightforward stuff, huh? See, this is easy, guys. No worries, no worries. All right, let's go to information theory. So this is a little bit on the fly, but some of you might kind of have an idea of what you're looking at. But I want to introduce the idea of information theory. So what is that? In physics, you can very much think of the material of study and the makeup, sort of the fundamental element, as atoms, matter, energy, so on and so forth, right? And that's traditionally often, I would say, certainly the way I was taught to think of reality in terms of physics. And it's not a bad framework. It's a great framework, very interesting framework. But sometimes it will emphasize the separation of things and won't really encompass informational relationships in the same way as thinking of things in terms of information theory. So more to that did not mean to do this, that the fundamental element in information theory can be thought of as the bit, which is kind of a reduction of information, of decisions, to sort of a binary choice, or it's a culmination of that, I believe. That binary is sort of that yes-no decision. One This is kind of, so let me see, what's a good example? So this table, for example, can be thought of as in terms of the atoms it's composed of. In the very same way, you would weigh it and take its mass. And that is a measure of its sort of, even, that can be a measure of energy, translated into energy even. And that you would then weigh this other table, for example, and you would compare their masses, and you could make a differentiation by that metric. So similarly, you can then consider the atom or the material or the composition of this table in terms of bits as information. And that you would then similarly be able to then weigh another table in those same terms. And ideally, if they are identical tables, they would contain the same level of information. And so, are there any questions so far? Is this all kind of making sense? Yes, no? Okay, good, cool. How many folks have heard of information theory before? Okay, great. I'm happy I brought it up then. Awesome. But yeah, so it can even get a little abstract. So think of a book full of information, right? And you take out a page of that book, and if you were to compare it to the book, what would be the most informationally dense of the two? Page or the book? Book, right. And so, again, you can kind of translate between, it's almost similar to if you were to take the mass. It's to have it be inherent in that way. Obviously, the book will be heavier than the page. Obviously, the book will have more information than the page, and so on and so forth. So that's kind of a key concept to that, and that another sort of measure, as much as I would say almost like a linking element between sort of the physics and information theory realm, is this function of entropy.
That's me. Don't worry about it.
All right. So to quote, and frankly, if you want to look further into this, Wikipedia is actually a really great resource that does a great job of kind of laying out in terms that I think are somewhat understandable in greater detail. So I'd be happy to provide all those resources after if you're curious. But to quote that. And there's a lot more to it. This is just really a quick intro so you guys can get familiar with this idea, possibly look into it, and just have that in your mind to think of information being able to represent objects in reality, and then we can then draw conclusions from sort of that framework. So like, for example, in terms of entropy with information theory, that identifying the outcome of a fair coin flip with two equally likely outcomes would provide less information, lower entropy, and less uncertainty than specifying the outcome from a roll of a dice with 6 equally likely outcomes. I can kind of try, it's not critical to understand that, but it's just in terms of conceptualizing, yeah?
What you are saying is that more information is more entropy.
Yeah, very much so. Great. Yeah. And so, but let's not get too far into the specifics, because for me it's very easy to get into these details and pull them apart. And get lost in that, but let's stay focused and move to an exercise. All right, let's try something out. So yeah, here we go. So all right, you have picture A, picture B, picture C. Would someone be able to tell me, in order from least informationally dense to most informationally dense, the order of these pictures? Hold on.
Same number of pixels.
Well, I'm gonna try and get someone else. Yes.
A, C, and B.
Right. And can you explain your reasoning?
Because A, this is the initial. Then C, you can see that there's like a gradient background, and then the color of one of the cans changed. And then B adds like the sun in the background.
True. Very true. You wanted to?
I was about to say that A has the least color, C has more for bed, and then B has the most color.
Very true. Anyone else have anything to add to that? Any questions about that? No? Well, I'll point out another thing, actually. There's words here. This is more information. So there is more color, for sure. But the additional wording would make this more informationally dense, because you've now labeled some of these objects with language. And just to reiterate, that's what we're talking about here. In information theory, we're communicating information, and the way by which we as people do that is through language. And even other animals, they communicate through vocalizations. And so even to think of it in those terms, that it's all, truly, all information. And so, let's see. And this is kind of interesting. I actually generated this with a AI tool that's freely available. Well, I'm sure I'm paying for it in some way. But nonetheless, this is what is publicly and easily accessible right now. I generated this picture of a dog. And then I went into Paint and I spruced it up. And so this is kind of one of the points I'd like to get to in this club, where we are using these AI tools to kind of cut down on work. Because I had a very specific idea in mind for the sort of picture that I was hoping to have. And I looked online, and ultimately, this took a minute to make. And this was just one of the pictures that I got. And so, yeah, it's you can even see it's a little funky. Where are its paws? Is this really a dog tag? You know, look at the collar, right? And then this is one of the nicer pictures. Even when you start to look at the detail here in the legs, especially, AI is challenged when it comes to generating limbs, especially with pictures. Kind of interesting, but it's not bad, and that's what we have right now. Isn't that wild? That's crazy, huh? Yeah.
It didn't generate the text, did it? You have to add that?
No, yes. So the color and the text, all that, I added in Paint. Yeah.
Because I was about to say, if it was able to be text, then...
Some of them can. Some of them kind of can, but they struggle with the combining the letters, the imagery of letters into language. So it's like, if that makes sense.
Yeah, it's usually just a jumbled mess.
Right, yeah. It's like much like a dream space. You know what I mean? Where the word won't look quite right. Do we have enough? We got enough chairs? Okay. So yeah, that's pretty cool, huh? And let's talk about that a little bit more. This is what I generated in a minute. And this is the prompt. Black and white cartoon dog with a collar that has a blank dog tag sitting next to a doghouse in a suburban backyard. Old school, black and white cartoon style. All right? Now let's look at these. And I just went with this one because this was kind of out the gate pretty good, right? And this one's not bad either. Looks a little, what's this though, right? What's that? What? It tried to make the dog tag here, and its eyes. Something ain't right. You know? This one's pretty good too. It even got the paws down. You know? This one's, I don't know. That one's a little, like, what's this? Maybe a leash or something? It got the doghouse though. You know, and then this one's not bad. I like this one personally. This one, I like that one. Yeah, this one here, it got the suburbia, you know, and not bad, better than I could do. This one, I don't know what it's doing over here. I don't know what this is. I like its face though, not bad, right? And that's over the summer, it was a couple years ago, you might have heard of Dolly Mini, or Mini Dolly, something to that effect. And this is now what it's been spun up into, I suppose, called Crayon, you know, AI in the middle there. Version 3. So they've definitely worked out their interface. It wasn't quite this nice when I was first messing with this stuff. It's crazy to see where it's gone in 6 months. And again, the prompt, I found the website, and now I got a bunch of dog pictures, you know? Crazy stuff. So, yeah, that's kind of to illustrate not just the idea of information density, but also just how capable the current free models are. And that you can absolutely use it to improve your work, do more work in less time. Yeah?
Why are they so bad at hands?
That's a great question, and I wish I could tell you, but it probably has something to do with the model. People struggle with hands all the time. So, yeah,
It would be like how they trained it with ants, like how they given it the data,
yeah.
how the input was.
Yeah, yeah. It would. That's true. It would really come down to the training as well. Yeah.
Why is it so difficult to make that name
It's a great question.
So, let me take this out of my ear so I can hear live. So it really comes down to detail. They're really good at doing textures. That's something that's consistent among almost all AI generative image bots. The problem is fingers are not a consistent texture. Your face is a pretty consistent texture, your hair is a pretty consistent texture, your clothing's a pretty consistent texture, but our hands are very dexterous. They can form many different types of shapes, they can be in many different types of, they move. And so because we have so much detail in our hands alone, just by how much we can move them and just how small it is, it's really hard for a AI to generate something that isn't very consistent in a sense. I mean, to us, we have bones, right? In our hands, it's pretty consistent to us. But to an AI that's just generating pixels, generating flows, and going from examples, it doesn't see like ligaments. It doesn't see that the bone structure that we have. It sees a pattern that it's trying to place on and then try to guess in between each pattern to make it move together. And so that's why it's harder for fingers, is because just how dynamic they are. Does that kind of explain it, or? All right, cool.
You can even see here, to kind of speak to the whole problem of small detail, that here it tried to do the tail. Emphasis on tried, I mean, here it's cleaner, but even in some of these, you can notice that it doesn't even include a tail, so just to kind of speak to that a little bit. But yeah, so any questions so far about like information density? I know we had some people walk in, so just to go back a little bit and quickly reiterate that we can see that there's a gradient of information density based on not just the addition of color, but also words. And that this would be considered less informationally dense than this picture. So A, the least, B, the most. And it's got a sun. All right, just to cover that real quick. And now let's do a fun Central Valley fact. Who knew that we grew a lot of almonds here? Yeah? Kind of, sort of? Yeah. Well, if you drive north or even towards the bay, around the valley.
Real quick, has anyone here had the brand Blue Almond brand from the store? Did you know that's packed here in Sacramento? It's kind of wild to think about. If you go downtown and just go around downtown, you'll run into a huge factory in the middle of Midtown and downtown. That's the Blue Almond Company.
Yeah, we grow a lot of almonds here.
Yeah.
A lot of almonds. And it takes a little less than, here in California, a little more than 2/3 of a gallon of water to grow one almond. Isn't that cool? Yeah, it's a lot of water. But in any case, that in this example, I kind of like to start introducing the idea of math as language. And we'll start just simply, though, with language itself. So I won't trick anyone. This is an almond tree. And that is, in fact, an almond. And that naturally, an almond will grow into an almond tree, right? So what's the point of this? The possibility of the almond tree has to reside within the almond. If it was a zero possibility of the almond tree coming out of the almond, there would be no almond tree. Does that make sense? Yeah? Conversely, in conjunction, that the almond tree must contain the possibility for the almond. For if the almond tree had no possibility of the almond, we would get no almonds from the almond tree. Right? That's pretty straightforward, right? So Why am I babbling about this? Well, because especially if you've invested a lot of capital and a lot of land into a crop of almonds, you'd like to know if your almond trees are going to make almonds, right? Or if you sell almond seeds as seeds to grow almond trees, it's the same story. So, and this is where we kind of start to find utility as analysts. That you must find how to encapsulate the possibility of the almond, of the almond tree within the almond, and be able to then articulate that in numbers or through visualization, your ability to articulate it to people who may not be able to connect those dots. And so, let's see. What if we were to consider, just for a second, this as a dependent variable? Dependent variable, so it depends on a number of other variables, right? What is one variable, and that this, let's consider the seed, that it already exists. It is in a state of existence. Informationally, we can interact with it, and it has a germination rate. So there's a possibility it will create the tree, right? So what is one independent factor, something outside of this relationship, that might influence, and let's just think in a linear fashion, if that helps at all. What is one factor that might help an almond turn into an almond tree? Yes?
The weather?
The weather, absolutely. Do you want to expand on that?
Like, if it's like too cloudy, it might not get enough sun and it might not germinate. Or
Right. Yeah, sunlight, absolutely. And we can measure sunlight. Yeah, for sure. Anything else? That's just one.
Water,
Water, yeah.
the soil,
The soil, great. Yeah. Fertilizer, yeah, nutrients. And it's that's definitely part of like the soil science, gauging the liveliness of the soil, like the microbiota and its nutrient levels, and that goes hand in hand as well. Anything else? Anyone? Yeah, yeah.
Invasive species that can harm it.
Absolutely, pests. How big is the pest population? Are we going to lose all the almonds, or the almond trees rather? The flowers, pollinators. These are all sort of what you would consider independent variables that would affect the linear growth rate, how big the tree gets. And I won't step through the whole process, but it's the same story but different. How many almonds can you get out of the almond tree? Very much, and that's all math. That's kind of logical thinking. And math is only a logical expression of the things we were just talking about. That's all it is. And so let's see if we can dig into that. Dig into that. There we go. Nope. Why is it doing that?
Where are you trying to go to?
That one. Yep. So this is where I really draw on my 196L class by Dr. Fitz, linear models and regression. Really great class. I'm not the most math-minded person, but it was fascinating, and I was able to get, I think, a lot of value out of that class. So don't let the experimental nature of the class scare you away from it. I think if you want to perform analysis, this will definitely open your eyes, I think, in a number of ways. But let's just make sense of the chart a little bit here. These here, data points, right? And there's, again, this is through what is almond tree, yep. And so this is what's considered a linear model, right? It's very simple too, simple linear model, and that. Oh, and I do have a resource, a book I can recommend if you're interested in going more into this. But outside of that, this I believe we're going to be using what's called the least squares method, which just carries some assumptions, but you don't really need to worry about all that right now. I'm just kind of trying to make math a little bit less scary right now and really, really hammer down the point that it is simply a language of expression through logic, and that you just need to learn the terms. And once you're able to kind of gauge that, you can then yourself look up truly what it is, how you need to express that through those symbols. That's all it is. That's all it is, folks. That here, this line, we use it as an approximation, a reduction in dimension even, that can represent these points of data. It is a trend even. We see it trends positive, whatever this data set is. So we can say these points could represent a relationship of sunlight per day, or sunlight hours per day, for example. And we can see in this example that the more sunlight you would get, the bigger that the almond tree might grow, right? And there's a bit of an explanation here, including sort of the idea behind the least squares method, where it has to do with the distance to this trend line. Don't worry about all that right now. If you're interested, good. And I can definitely get you guys the resources that might be able to explain that in greater detail. But let's now, we've discussed it in terms of language. Let's do a little bit of turning that language, translating it into this very simple formula here. So y is your dependent variable. So how big does the almond tree get? Y equals your dependent variable, x. Sunlight, or did I say dependent? Independent variable. Sunlight, soil nutrient density, pest population, you name it. That is your dependent variable that will ultimately decide the dependent variable, right? And that then in this model, you have the betas here, which this is actually technically, I believe, the intercept. But in any case, that's your coefficient. So kind of the rate that the model is able to approximate how the independent variables influence the dependent variable. If everyone caught that. Any questions so far? You didn't? Okay, so yeah, sure. So yeah, so that the coefficient, the beta naught and the beta 1 there, are multiplied to the independent variables that kind of then express this trend line, I suppose, in a sort of way, that allow you to kind of predict to some degree this dependent variable, given you're picking the right independent variables. Did that help at all? It kind of, it moves the line, or the model has kind of been able to identify the coefficient by which the linear rate of change, if that helps at all. Yeah?
Wait, so what does beta 0 and beta 1 represent?
So we spoke about, great question. We spoke about several variables that could influence the growth of an almond tree, right? And that's kind of what you would see then there. You're able to kind of plug in those independent variables into a more complete equation. You can do very simple ones. There's definitely a relationship between sunlight hours and the size of a tree, but you would probably get a bigger picture, more information. And if we're thinking with information theory, that it's all kind of in terms of information, that you're able to capture more of the story with more variables. So the better the soil, the bigger the tree, the more sunlight, the bigger the tree, so on and so forth. Does that help?
Yes.
Okay, great. And so just to dip a toe into it a little bit further, let's see. Yeah, I got it right. Oh, and this is your error. And that's cool for experimental stuff, but don't worry too much about that. But this just kind of shows you, there's your intercept, and then here's your sunlight hours, perhaps. Here is your soil nutrient level, perhaps. And you can just grow this model. And sometimes that's not a good thing. Sometimes you don't want a big model, but I'll let you guys explore that, because I think But actually, what time is it?
We
Okay.
got 10 minutes.
So, does anybody have any questions so far about sort of the yeah?
Aren't the variables vectors?
They can be, yes, most certainly. I mean, you can definitely express them in a matrix, yes, and that actually that's basically what the language models are in very simplistic terms. That you can think of what they're doing is weighting these kind of matrices and with words after seeing a number of words, and then they are just trying to pick the next word. So the next word is your dependent variable, and the independent variables are all the language it's seen before and all the ways it's been able to kind of put that into the model. If that, I think I went a little outside the question, but did that help? Okay, cool. So yeah, math is a language, guys. It's pretty cool. And I don't think that's really the way they tend to teach it. They oftentimes want you to really get the proofs down and stuff. But for me, I was not interested in doing those kind of mechanical operations until I understood what I was trying to say. It's the same, I suppose, with any language, right? That until you kind of know what to say, you're just going to speak nonsense almost. And that, that it's a way to express sort of the world around us and perform analysis, find the patterns, identify them discreetly, assign numbers, metrics that people typically will be able to understand, articulate that to them, and then they pay you for that. You know? All right. I think that's about, let me see, is that what I got?
For anyone wondering what that loud screeching is, which fortunately the stream can't hear, there's a mercury valve in there and it's kind of freaking out. So there's a temperature gauge over there, and that sound
it's fine,
is...
it's fine. I'm sure we're up to code here, right?
Yeah.
Okay, so here's something I'll kind of...
We're not going to die, that's all.
I'll give you guys a few minutes to maybe think of sort of maybe... You don't have to express it in these terms, but name just one, think for yourself for like 5 minutes, independent variable and a dependent variable. So just take a minute in the world around you. Think of perhaps what is something dependent variable depends on an independent variable that you might be able to gauge this way. So I'll just give you guys a couple minutes. And just to add, I will have you share that idea to the person next to you, and then I'm going to ask for someone to volunteer one of their ideas. So just keep that in mind. I'll give you another minute. And feel free to talk. Feel free to discuss your idea. Don't let me stop you. Yes. And this is just a linear expression. So there's behaviors that will not be explained in this model. Well, this like a crawl before you walk, which was very much like I think that's the I think you're trying to walk. It was interesting. In the class, we went from simple linear regression through these lanes of squares, and then there's a whole thing called logistical regression, which has to deal with like binary probabilities, and that kind of builds on this idea. And then
That's what I want you to present.
well, that would be like more a technical thing. Yeah, well, I want to get people comfortable outside of this idea that now is like some dead process.
This is good, because that's interesting.
Right.
And that gets people going to then do lower stuff.
Well,
I feel like
I suppose we all have our
trust me, it works.
for me, I need like the purpose before I because there's a whole proof to this that I did not follow and I did not care to follow until sort of until we started actually discussing it, because there's this undeniable link of information relationships.
Out of curiosity, are there still cookies back there? R&D, but there's still cookies? Yeah. All cookies are gone? Okay, cool. Alright,
Do you want to get out of here at 3:30, or I just have to open up at 3:45? I see what you're saying. Copy. All right, everyone. All right, let's come back for just a minute. It was awesome that y'all kept going, but just to keep ourselves in time, did anybody have an idea that they wanted to share? Don't be shy. No wrong answers. This is a learning experience.
Rather, what have you guys noticed in general?
Or like an example.
So like if I wanted to graph how fast my phone's battery goes down,
Yeah.
I think I could do like the dependent variable being the battery percentage, or like the change in it.
Sure.
The independent variable could be like how long my screen's on.
Independent variable. You're thinking in the right direction. It would be, I think it would be inverse to that, where the dependent would be the number increasing or decreasing from the independent. How long do you have your screen on? Is that?
I think that's.
Is that what you said?
Yeah.
Oh,
I said
sorry.
dependent is battery, right?
Dependent. Well, so maybe I misheard. My bad. So okay, but yes, in that case, you would be correct. That the dependent would be that battery, and that the independent would be the phone screen. Yes, absolutely. And they even chart it on your phone for you. That I would assume encompasses all sorts of different variables. But yes, absolutely correct. Anyone else? Anyone else? Yes.
Would you be able to come up and speak a lot louder, or? That works.
Sure.
Wait,
Whatever
your
you want.
microphone. Whatever.
Okay, so this would be like a real estate example. So
Yeah.
the dependent variable would be like the price of a house,
Mhm.
and the independent would be like square footage.
Yeah, for sure.
Repeat what they
Absolutely.
said.
Huh?
Repeat what they said.
Yeah, so that would be, she said that I believe the dependent variable would be for example, the price of a listed house, and that the independent variable to that would be the square footage. Great example. Yes. Anyone else? Anyone else? It seems like you guys got it. Yeah? Yeah? Yeah, sure, yeah.
I was thinking like, say you have like an image,
Mm-hmm.
and you wanted to ascribe a value of how happy the person is.
Mm-hmm.
You would like somehow get like a number value. Say like independent variable, one would be like the curvature of their mouth. Is it curved up?
Beautiful.
You would
Yes.
ascribe a number to that, and then like other stuff like eyebrows, just what you think makes a person more happy.
Absolutely. Seems like you guys got it. Yeah, that's actually in part probably what's happening in those models in Face ID and stuff like that. I mean, generally speaking, yeah, that's I believe what they're doing in some capacity. Though we're not quite sure how the models are able to sort it out specifically, but yeah, now you're thinking like a scientist with data, right? All right. So to kind of wrap up.
Wait, repeat what their statement was again?
Just that, like, you could identify sort of perhaps the sentiment of a picture of a person, their face, whether they're smiling or not, for example, based on sort of the curvature of their smile. You know, like that a smile has a particular shape that you might be able to identify, and that would be an independent variable to like a picture, which is great. Yeah, absolutely. But yeah, so I mean, you guys came up. I had an example, but you all came up with some better examples, so I'm gonna leave it at that. I hope anyone feel a little bit different about math now, maybe, kind of, sort of. Yeah. I see some thumbs up. Cool. Very cool. All right. Well, that's what I have for you. I hope you guys enjoyed it. I hope it was a little informative. I hope it got you a little more interested in data science. And yeah, feel free to hang out. I'll be here till about 4. And if you want, I can put some more resources in the Discord resource tabs, these kind of video snippets that I think kind of encapsulate a couple of the key ideas that we expressed today. All right, thank you so much. I'm glad you all came up.
Sorry. So
Go ahead, Aaron.
if you do want to get more resources, these 2 videos are pretty good. Let me throw it up on the live stream so you guys can check it out later if you want. Oh my gosh, it's way down there. What is the slide? Slide 4? Perfect, slide 4. Push this up to the top. So we're also probably going to be doing a game night at some point. If anyone is interested in that, let me know. We're probably going to be doing something like Mario Kart or Mario Party. Furthermore, we're also looking to do some events outside of the club meeting. So maybe doing something like going to a company, such as a sleep apnea company, and see how those types of situations can use data science to help track, say, a person's sleep schedule to see what medical conditions they might have. Though we will probably have to clear that since as a medical
we might be able to like tour office.
Yeah, we're looking to try and tour different offices. We're also looking for sponsorships. So if you have a company that you are currently working at, if you are working or you're currently working at and is looking to get rid of some money and wants to sponsor a cool club, ours is looking for sponsorships. Furthermore, I apologize. I've been outside all day and my brain is completely fried. But yeah, we're going to try and do some stuff outside of the club events for just community stuff. We're going to try and do some tours, sponsorships, and as always, please, let's get rid of the food. And if you haven't signed in, please make sure to sign in. Anything else I'm missing?
That's everything I got.
All right, one more time. Look to your left, look to your right, introduce your name, major, and some cool animal that you know of. Woo! That's one, but
it seems like everyone got the idea.
Oh yeah. This is actually the last thing. So something we've done in previous semesters is that we usually end off the live streams by waving at the camera. A few of you guys have been here last semester and know what we're talking about. If anyone is interested in doing it and coming up to the front and just doing a big goodbye to the camera, anyone up for that? All right, come up here. It honestly looks pretty cool on the live stream, so it also helps with thumbnails. So
you're filing this way.
Yeah, no, just in front of the camera, or just in front of the table. The camera's there. That big old one in the back. It's fun.
All right.
It's not the same as like the ones inside the classrooms, but you know. All right, goodbye on camera. 1, 2, 3. Goodbye. All right, we're good. Woo!
Thanks for coming, guys. Thanks for coming. Again, if you want to hang out, feel free.
We're here till 4. At 4, we all have to get out of here. But again, food. I need it gone. Oh, signage.
If you need to sign in, still, QR code's up on the.
I have a question.
So,
This is probably something I should ask Professor Fitz, but we're getting more information on like the stuff over here. Is taking stat 128 and stat 129 good idea?
Yes, those are actually the two data science courses. Let me get off this way. So those are the two like data science focused courses that we have.
There's a lot of interest in and the logistics are challenging.
So that's like a project like very well data and industry charts. It's very good for data analytics. 190. So when I do this,
yeah, you can see it.
the other one. Or six, yeah, so six.
I got a question.
That
So
one
how often are the meetings?
We're trying to do once a week on
Yes. At the same time, 2:30?
Yes, sir.
Okay. Will it be the same room as well, or?
I think next time's going to be in the green and gold room.
Green and gold room?
Here they also use like a
Yeah, for sure.
Yeah. So languages and
Oh, yeah.
Python is more coder based. R is more
Yeah, I mean, mycology is fascinating, especially when you think of yeast, which is like a fundamental sort of living being that
the more you use
the way we produce bread is a fungus.
But that's the way that works. It's a really nice language.
Yeah, and the only reason we have dirt, the reason why we have dirt, the way we have dirt, is they grow these like tendrils of mycelium into mediums like wood, typically. Those are mostly the edible mushrooms are the kinds that grow on wood, and they secrete like enzymes that then breaks down. They're decomposers, and so they absorb the nutrient that way. And when you see them like this, they're blooming. So most of the fungus will exist in the mycelium, and this is called the fruiting body.
That's like the stuff they
You would need to get like spores, which they sell like bags of like I'm a little tired. They sell like bags of mediums that you can like populate with a fungus, and then it will grow out, and you can pull in the bag, and it's like that's what I'm look up on Amazon like mushroom. Yeah, you might find some stuff. What now? No. Yeah, don't worry. All right. Yeah, for sure. Thanks for coming by. Yo Club too. We don't charge it.
Okay.
Yeah.
Meetings every Tuesday or every
Thursday. We're going to try and stick to Thursdays, but I've had some people say they're interested in alternative meeting times, so I might try and gauge that, see who would show up at a good time. That's the thing. Yeah, we're gonna. It might shift to 3 depending on how early they let us in the room, but we'll try and let you know ahead of time as much as possible.
days I'm able to go. I may be a little late because that's at a tail end.
Yeah, don't worry about it. If you need to, there's no cutoff point. So if you show up late, even like halfway through, and you want to sign in, just come up afterwards, put the thing back up, and you were here. You know? We're just trying to get people interested. Yeah.
Thank you.
Absolutely. Yeah, for sure. Thanks for coming in.
Is there a shortage of
The demand is very high. It depends, I think, where you are. So I would say if you're in the middle of the country, probably there's a shortage. The most degree programs, I think, are impacted. Yeah. Well, it depends. Most programs are big enough because it's such a high demand field that it's lucrative and all that. They generally most schools don't have enough resources. I mean, is there a shortage? I think growth is like demand is outgrowing expected projections of Demand's so high. You could say it's a shortage, but there's so many technical, it's like, I don't know, it might be kind of
Oh no, you're fine. Bye. Nobody handles
Sometimes
you're not. Like, oh, by the way, like projects pull everything that I would have to. So it's players too, but if you have $200 that you can't really leave out the current project that the club is trying to push. I think if I joined the drone project, there we go. That was that. The drone project. Yeah.
It'd be a good learning experience.
Why don't you recite? I forgot your name. Why don't you recite major? I remember it was like you went to Hackathon and you were just like looking at it and then I saw that face of terror and that's burned into my mind. I would look up OpenAI resources. If you're looking for that was the first time I realized like, oh yeah, AI is taking jobs. How is it with Scott training AI is more of a general thing. There's more advanced stats.
That's all over
Yeah, yes.
So you taking it? You taking 190? You taking 190?
Are you familiar with all at all, or do you try and avoid it like to play like the same humans?
not really.
You gotta learn it. It's so I love it. You can just give it like a 3 gigabyte file. It's like that. Yeah. It's kind of old too. That's what's so weird. It's growing, but it's